Hey there, engineers! Have you ever looked at the Great Pyramid or the Roman aqueducts and wondered, how the heck are these still standing? These ancient marvels aren't just relics of the past, they're clues to a sustainable future. In a world where resource management and sustainability are key, ancient engineering can offer some pretty groundbreaking solutions. Let's dive in. First up, Roman concrete. Have you heard of it? Unlike modern concrete, which can degrade over time, Roman concrete has stood the test of centuries. Researchers have discovered its secret, a unique mix that includes volcanic ash. Today, scientists are looking into these ancient recipes to create more durable and eco-friendly concrete for our infrastructure. And then there's the Persian qanats. These ancient underground aqueducts were designed to transport water across vast deserts without losing it to evaporation. They're an ancient answer to modern water scarcity issues. Engineers are now exploring similar methods to bring water to arid regions sustainably. Let's not forget about the ancient Greeks and their use of passive solar design. They oriented buildings to optimize sunlight, reducing the need for artificial heating. Sounds familiar? Modern sustainable architecture is tapping into these age-old principles to create energy-efficient buildings. So, next time you're brainstorming innovative solutions, don't just look forward, look back. The wisdom of ancient engineers might just hold the keys to solving today's challenges. If you found this intriguing, hit that subscribe button for more mind-blowing engineering insights. Until next time, keep building a better future. Forgotten wonders, ancient engineering marvels, the pyramids of Egypt, the Great Wall of China, Machu Picchu. These ancient wonders inspire awe. They are testaments to human ingenuity. Our ancestors, with limited tools, achieved incredible feats. They understood their environment. They used resources wisely. Their creations have stood the test of time. Ancient engineering is more than just impressive structures. It represents a deep understanding of the world. Ancient builders and engineers were keen observers. They learned from nature. They adapted to their surroundings. They developed techniques that were both practical and sustainable. Learning from the past. Ancient solutions for modern problems. Today we face complex problems: climate change, urbanization, resource depletion. Ancient civilizations faced similar challenges. They developed innovative solutions. These solutions were often sustainable and in harmony with nature. Consider the ancient Inca. They built cities high in the Andes Mountains. They faced earthquakes and harsh weather. Their solution? A sophisticated system of earthquake-resistant buildings and agricultural terraces. These innovations allowed them to thrive in a challenging environment. Or look at the ancient Romans. They built aqueducts to transport water over long distances. These aqueducts used gravity, not energy-intensive pumps. They provided a reliable water supply for cities and agriculture. These examples demonstrate the power of ancient engineering. They offer practical solutions that are relevant even today. By learning from the past, we can create a more sustainable future. The Roman aqueducts, a water management masterpiece. Water is life. Ancient civilizations understood this well. The Romans in particular excelled at water management. Their aqueducts were engineering marvels. They brought fresh water to cities across their vast empire. These aqueducts weren't just pipes, they were complex systems. They used gravity to transport water over hills and valleys. Tunnels were carved through mountains. Bridges carried water across rivers. The precision and scale of these projects are astounding. The Roman aqueducts weren't just about functionality, they were also beautiful. The arches and bridges became iconic landmarks. They symbolized Roman ingenuity and power. Today, these aqueducts still stand, a testament to Roman engineering prowess. They remind us that sustainable solutions can also be aesthetically pleasing. They inspire us to find innovative ways to manage our resources. The qanat system, sustainable water harvesting from ancient Persia. In the arid regions of ancient Persia, a different water management system thrived, the qanat. This ingenious system tapped into underground water sources. It transported water over long distances using gravity. The qanat system involved a series of underground tunnels. These tunnels were dug at a slight slope. They collected water from underground aquifers. Vertical shafts were dug at regular intervals. These shafts provided ventilation and access for maintenance. The qanat system was remarkably sustainable. It relied on gravity, not energy-intensive pumps. It minimized water loss through evaporation. It provided a reliable water source for centuries. Today, the Kanat system is still used in some parts of the world. It serves as a reminder of the ingenuity of ancient civilizations. It offers a sustainable solution for water management in arid regions. Section 5. Earthquake-resistant architecture lessons from the Inca. The Inca built their empire in a seismically active region. They faced the constant threat of earthquakes, yet their structures survived. How? They developed earthquake-resistant building techniques. One key technique was the use of carefully shaped stones. These stones were fitted together with incredible precision. No mortar was used. This allowed the structures to move slightly during earthquakes. The stones would dance and then settle back into place. The Inca also used trapezoidal doorways and sloping walls. These features helped to distribute the weight of the structure. They reduced the risk of collapse during earthquakes. The Inca understood that they couldn't prevent earthquakes, but they could adapt their building techniques. Their earthquake-resistant architecture allowed them to live in harmony with their environment. Section 6. Traditional knowledge and climate change, adapting to a changing world. Climate change is one of the greatest challenges of our time. Ancient civilizations faced climate variability. They developed strategies to adapt. Their traditional knowledge can offer valuable insights. For example, indigenous communities around the world have long practiced sustainable agriculture. They have developed techniques to conserve water, preserve soil fertility, and adapt to changing weather patterns. These traditional practices are often based on a deep understanding of local ecosystems. They are passed down through generations of observation and experience. They offer a holistic approach to managing resources and living in balance with nature. By studying and respecting traditional knowledge, we can learn valuable lessons about adaptation and resilience. We can find inspiration for developing sustainable solutions to the challenges of climate change. Section 7. Balancing progress with heritage, preserving our past while building our future. Progress and tradition are often seen as opposing forces, but they don't have to be. We can embrace progress while respecting our heritage. We can learn from the past while building for the future. Preserving ancient structures and archaeological sites is crucial. These sites are not just tourist attractions. They are valuable sources of knowledge. They offer insights into the lives, beliefs, and technologies of our ancestors. But preservation doesn't mean stagnation. We can adapt ancient techniques to modern needs. We can integrate traditional knowledge into contemporary design. We can create buildings and infrastructure that are both functional and aesthetically pleasing, honoring the past while embracing the future. Section 8. Inspiring future innovation, ancient wisdom for modern technology. Ancient engineering wasn't just about brute strength or simple tools. It was about observation, ingenuity, and a deep understanding of natural principles. These principles can inspire modern technological innovation. For example, the aerodynamic design of birds inspired the Wright brothers' invention of the airplane. The study of bioluminescence in fireflies has led to advances in LED lighting. The list goes on. Ancient structures and technologies offer a treasure trove of inspiration. By studying the principles behind their design and functionality, we can unlock new possibilities for innovation. We can develop technologies that are both efficient and sustainable, drawing on the wisdom of the past to create a better future. Section 9. Ancient engineering, a bridge to a sustainable future. We live in a world facing unprecedented challenges. Climate change, resource depletion, and environmental degradation threaten our planet. Ancient engineering offers a path forward. By learning from the past, we can build a more sustainable future. We can adopt ancient water management techniques, develop earthquake-resistant buildings, and find inspiration for new technologies. Ancient engineering is more than just history. It is a valuable resource. It is a bridge connecting the wisdom of our ancestors to the challenges of our time. By embracing this legacy, we can create a world that is both innovative and sustainable, honoring the past while building a brighter future for generations to come. Ancient civilizations were incredibly resourceful. They developed ingenious solutions for the challenges they faced. Today, engineers and architects are rediscovering these ancient techniques, finding new ways to use them. These ancient solutions are inspiring modern innovations, offering sustainable and efficient ways to address present-day problems. Ancient civilizations observed nature closely and learned from its patterns and processes. This approach, known as biomimicry, is gaining traction today. By emulating nature's designs, we can create more sustainable and efficient technologies. The legacy of ancient builders is evident in modern construction. From the precision of Egyptian pyramids to the grandeur of Greek temples, these structures continue to inspire. Modern engineers are learning from these ancient techniques and incorporating them into contemporary building practices. Biomimicry is a fascinating field. It involves studying nature's designs, which have been perfected over millions of years. Engineers and scientists then adapt these designs to solve human problems. Take the example of wind turbines. Wind turbines generate clean energy. Their blades are inspired by whale fins. Whale fins have bumps called tubercles. These bumps reduce drag and increase lift. Wind turbine blades with similar bumps produce more energy and operate more quietly. Another example is the kingfisher's beak. This bird dives into water with minimal splash. Engineers studied its beak shape and used it to design the Shinkansen bullet train in Japan. The train's nose is similar to the kingfisher's beak, which reduces noise and improves efficiency. Ancient civilizations were masters of construction. They built impressive structures that have stood the test of time. The Egyptians, for instance, were renowned for their precision. They used simple tools like plumb bobs and leveling instruments. These tools helped them achieve remarkable accuracy in their buildings. The Greeks were known for their mastery of masonry. They built magnificent temples using carefully cut stones. These stones were fitted together without mortar. This technique required great skill and resulted in remarkably durable structures. The Romans were renowned for their engineering prowess. They built vast networks of roads, aqueducts, and buildings. They used concrete extensively. Their concrete was incredibly strong and durable. Modern engineers are studying Roman concrete to replicate its longevity. The Romans developed a sophisticated heating system called the hypocaust. This system used raised floors with hot air circulating beneath these floors to heat the rooms above. Hypocausts were remarkably efficient, providing even heat distribution. Today, architects and engineers are rediscovering the hypocaust principle and adapting it for modern buildings. Modern hypocaust systems use underfloor heating, which reduces energy consumption and provides a comfortable living environment. Section 5, Shinkansen and the Kingfisher Biomimicry and Transportation. The Shinkansen bullet train in Japan is a marvel of engineering. It can travel at speeds up to 320 kilometers per hour, or about 200 miles per hour. One of the challenges of high-speed trains is noise pollution. The Shinkansen engineers found a solution in nature. They studied the kingfisher, a bird known for its diving skills. The kingfisher can dive into water with minimal splash. This is due to the shape of its beak. The engineers designed the nose of the Shinkansen train to mimic the kingfisher's beak. This reduces noise and air resistance. Section 6, From Burdock to Velcro. Nature-inspired innovation. Sometimes the simplest solutions are the most effective. This is certainly true for Velcro. It was invented in 1941 by Swiss engineer Georges de Mestral. De Mestral was inspired by burdock burrs. These burrs stuck to his dog's fur. He examined the burrs under a microscope. He discovered tiny hooks that attached to the fur's loops. This inspired him to create Velcro. Velcro consists of two strips. One strip has tiny hooks, the other strip has loops. When pressed together, they form a strong bond. Section 7. Sustainable building, the revival of traditional materials. In a world facing climate change, sustainable building practices are crucial. Architects and engineers are turning to traditional building materials. These materials are often more sustainable than modern alternatives. Adobe, for example, is a natural building material made from clay, sand, and water. It has been used for centuries in hot, arid climates. Adobe is energy efficient. It helps regulate indoor temperatures. Rammed earth is another ancient building technique. It involves compacting a mixture of earth, gravel, and a stabilizing agent. Rammed earth walls are strong and durable. They also provide excellent insulation. Section 8. Ancient concrete rediscovering durability. Concrete is one of the most widely used building materials today. However, modern concrete can deteriorate over time. Roman concrete, on the other hand, is known for its incredible durability. Some Roman structures have stood for over 2,000 years. Scientists and engineers are studying Roman concrete. They want to understand its secrets. They have discovered that the Romans used a different recipe. Their concrete included volcanic ash. This ash reacted with seawater. This created a remarkably strong and durable material. Researchers are now experimenting with Roman concrete recipes. They aim to develop more sustainable and long-lasting concrete for modern construction. Section 9. Conclusion. Bridging the past and future of engineering. As we face new challenges in the 21st century, it is essential to look back at the wisdom of the past. Ancient civilizations developed ingenious solutions for the problems of their time. Many of these solutions are still relevant today. By studying ancient engineering techniques and embracing biomimicry, we can develop sustainable, efficient, and innovative solutions for a better future. The past holds valuable lessons for the future of engineering and beyond. The ancient world is filled with incredible structures that continue to amaze us today. These engineering marvels, built with the technology available at the time, stand as testaments to human ingenuity and capability. They offer fascinating glimpses into the past and hold valuable lessons for the present. By studying these structures, we can learn from the innovative solutions our ancestors devised and apply those principles to modern challenges. These ancient wonders were not merely feats of engineering, they were also solutions to real-world problems. The challenges faced by ancient civilizations were often similar to those we face today: how to manage resources, build lasting structures, and create a sustainable way of life. Let us delve into two specific examples of ancient engineering marvels, the pyramids of Giza and the Roman aqueducts, and explore the lessons they hold for us. The pyramids of Giza, standing tall on the sands of Egypt, are perhaps the most iconic symbols of ancient engineering. Constructed as elaborate tombs for the pharaohs, these massive structures are a testament to the Egyptians' advanced understanding of mathematics, astronomy, and logistics. The sheer scale of the pyramids is awe-inspiring, with the largest, the Great Pyramid of Giza, originally standing at 481 feet tall. To construct these colossal monuments, the Egyptians employed ingenious techniques and a highly organized workforce. Massive blocks of stone, quarried from nearby sites, were transported and lifted into place using a combination of ramps, levers, rollers, and sheer manpower. The precision with which these blocks were cut and fitted together is remarkable, with some joints so tight that a knife blade cannot be inserted between them. The construction of the pyramids was not merely a feat of brute force. It required meticulous planning and a sophisticated understanding of geometry and astronomy. The alignment of the pyramids with the cardinal directions is incredibly precise, demonstrating the Egyptians' advanced surveying techniques. They used a system based on the stars to ensure the pyramids were perfectly oriented, reflecting their belief in the celestial significance of these structures. The interior chambers and passageways of the pyramids are equally impressive, featuring intricate layouts and ingenious architectural features. The placement of these chambers and the shafts that connect them to the exterior suggest an understanding of air circulation and ventilation. These elements highlight the multifaceted nature of the Egyptians' knowledge and their ability to incorporate both practical and symbolic elements into their constructions. While the pyramids are often viewed as symbols of power and eternity, they also offer insights into the sustainable practices of the ancient Egyptians. The use of locally sourced materials, primarily limestone quarried from the Giza Plateau, minimized transportation costs and environmental impact. This approach resonates with modern concepts of sustainable building, emphasizing the use of local resources to reduce the carbon footprint of construction. Furthermore, the design of the pyramids themselves exhibits an understanding of passive cooling and heating. The thick walls and the pyramid's shape help to regulate the internal temperature, keeping the interior cool during the scorching Egyptian summers and relatively warm during the cooler months. This natural ventilation system reduced the need for artificial temperature control, aligning with modern efforts to create energy-efficient buildings. Section 5. Roman aqueducts, engineering for water management. Shifting our focus from the arid deserts of Egypt to the Roman Empire, we encounter another marvel of ancient engineering, the aqueducts. These impressive structures, spanning vast distances across hills and valleys, stand as a testament to the Romans' mastery of water management and their commitment to providing a vital resource to their cities. The aqueducts were not merely functional conduits. They represented the Roman Empire's power, ingenuity, and dedication to the well-being of its citizens. The Romans constructed aqueducts throughout their vast empire, utilizing a combination of innovative techniques and a deep understanding of gravity. They carefully surveyed the terrain to determine the most efficient routes and gradients for the water to flow. The aqueducts were typically built with a slight downward slope, allowing gravity to propel the water over long distances with minimal loss of pressure. Section 6. Gravity-defying feats of Roman aqueducts. To overcome geographical obstacles, the Romans employed a variety of ingenious methods in the construction of their aqueducts. Tunnels were dug through hills and mountains, while bridges and arches were erected to carry the water channels over valleys and rivers. The Pont du Gard in southern France, a UNESCO World Heritage Site, is a stunning example of a Roman aqueduct bridge with its 3 tiers of arches reaching a height of 160 feet. The aqueducts were built using durable materials like stone, brick, and a revolutionary material developed by the Romans, concrete. This new material, made from a mixture of volcanic ash, lime, and aggregate, proved to be incredibly strong and long-lasting, contributing to the longevity of many Roman aqueducts, some of which are still partially functional today. Section 7. Timeless lessons for modern challenges. The pyramids of Giza and the Roman aqueducts, though separated by time and geography, share a common thread. They represent innovative solutions to the challenges faced by their respective civilizations. These engineering marvels offer timeless lessons that continue to resonate with modern society, particularly in the face of growing concerns about sustainability, resource management, and urban planning. The ancient builders' emphasis on using locally sourced materials, as seen in the pyramids' limestone construction and the aqueducts' use of readily available stone and concrete, provides a valuable lesson for contemporary construction practices. By minimizing the transportation of materials, we can reduce the environmental impact of building and promote a more sustainable approach to urban development. Section 8. Ancient inspiration for sustainable architecture. The principles of passive heating and cooling employed in the pyramids, utilizing the structure's design to regulate temperature naturally, offer inspiration for modern architects seeking to create energy-efficient buildings. By incorporating similar concepts into contemporary designs, such as utilizing natural ventilation and maximizing shade, we can reduce reliance on energy-intensive air conditioning and heating systems. The Roman aqueducts' reliance on gravity for water transportation, carefully planning the gradient and route to ensure a consistent flow, holds relevance for modern water management systems. While modern technology allows for more complex pumping systems, understanding the principles of gravity-driven flow can lead to more efficient and sustainable water distribution networks. Section 9. A legacy of ingenuity. The ancient engineering marvels of the pyramids of Giza and the Roman aqueducts stand as enduring testaments to human ingenuity and our capacity for innovation. These structures, built with the tools and knowledge available at the time, continue to inspire and offer valuable lessons for addressing contemporary challenges in sustainable building practices, resource management, and urban planning. By studying the past, we can gain a deeper understanding of the present and find inspiration for creating a more sustainable and resilient future. The ingenuity of our ancestors reminds us that even with limited resources, human creativity and determination can overcome seemingly insurmountable obstacles and leave a lasting legacy for generations to come. The past can teach us. Ancient civilizations thrived for centuries. They faced challenges just like we do. They developed ingenious solutions, many forgotten by time. These ancient solutions offer valuable lessons. We can learn from their successes and failures. By studying ancient engineering, we gain insights. We can find new ways to approach modern problems. Ancient wisdom can inspire sustainable practices. We can create a better future by learning from the past. Ancient civilizations lived in harmony with nature. They understood the importance of balance. Resource management was crucial for their survival. Many societies developed sustainable practices. The Inca built sophisticated irrigation systems. These systems channeled water from the Andes. They transformed arid lands into fertile fields. The Romans excelled in water management too. Their aqueducts carried fresh water over long distances. Ancient Egyptians understood the Nile River's cycles. They timed their agricultural practices accordingly. This ensured bountiful harvests year after year. These examples demonstrate deep respect for nature. Ancient engineering continues to inspire us. Modern architects marvel at Roman concrete's durability. We study ancient structures for earthquake resistance. The principles used in their construction remain relevant today. Biomimicry, a growing field, draws inspiration from nature. Ancient civilizations often used natural designs. We can learn from their observations and applications. For example, the aerodynamics of bird flight inspired ancient gliders. Today, engineers study these designs for more efficient aircraft. Ancient solutions offer valuable insights. We can adapt these solutions to modern challenges. By understanding the past, we can innovate for the future. The past holds keys to a sustainable future. By exploring ancient engineering, we broaden our perspectives. We discover the ingenuity and resourcefulness of past civilizations. We can learn from their mistakes as well as their triumphs. This knowledge can guide us towards a more balanced relationship with our planet. Let us explore the past. Let us learn from ancient wisdom. Let us build a future inspired by the ingenuity of those who came before us.